Okay, now we're going to talk about vectors versus... Children, if you have your phones out in class, we will have a bucket of water and we will throw your phones in it as the... Nah, it's not true. I'm just joking. You going to leave that in there? You have to talk. Say yes or no.
Yeah.
Okay, good. Okay, no, so vectors versus scalars, okay? Is that good size? Yeah? Okay. Good enough? Perfect. Okay. So vector versus scalars. So when we have our measurements, let's take the 3 measurements that I talked about in another video. Mass, kilogram, that is mass. What am I talking about? Mass, length, and time. Okay? Now, when we take these measurements, they tend to fall in one of 2 categories, either vectors or scalars. Okay? A scalar is simply a number. I'm driving down the road. I have no idea where I'm going. Hey, I'm going 35 miles per hour. That's a scalar. Okay? It doesn't tell direction or anything else. So for a scalar, we say that it only tells us the magnitude, meaning how much. Okay? Now, if we think about it, mass, a kilogram. Hey, this is 5 kilograms. That's it. It's a magnitude. So mass would always be measured in scalars. Okay? It doesn't tell us what direction or anything. It just tells us an amount. Now, on the other hand, vectors, they give us the magnitude and the direction. Okay? So if I say I'm going 35 miles per hour, it's a scalar. If I say I'm going 35 miles per hour east, it's a vector. Okay? It's a vector because it actually tells us some direction. So mass would always be a scalar. How about length? Length could kind of be both. All right? So length could be measured in something called displacement. Okay? And displacement is what we use a lot in physics. All right? So mass is m. Displacement is in physics an x. Okay? And so if I say, okay, I moved 5 feet to the right. I picked this ball up from the table and I moved it 1 meter in the positive y direction. Okay? That would be an example of a vector because I tell you how much and in what direction. Now time you could say always has a direction, which is true. It just always increases. So there's no real changing of direction. So for that case, it's actually a scalar. Okay? Now, a lot of times in physics, in what we do in class, we just have a lot of vectors. Okay? A list of scalars would be mass, time, temperature. You'll say, well, wait a second. There's like negative temperature and positive temperature. Yeah, but they're still just amounts. It's not moving a certain direction or pointing in some way. So time, mass, anything else? Temperature. Those are the big ones for scalars. Okay. Now vectors, on the other hand, we have something called velocity. We have displacement, acceleration, force. Okay? Because when we have objects moving, they're always moving left, right, up, down, at some angle, somewhere. Okay? And to tell what the object's doing, we need to give it more information. So vectors always give more information. Now there's 2 ways to show a vector. Okay? 2 ways to show, you can see one right here. You put that little half arrow over it. Right? So if we had a textbook, textbooks don't really have the ability, they probably do now. I don't know. I'm an 80s and 90s child. So if we had X, we show it by putting the half arrow over it, even when we write. Textbooks don't really have that probably half arrow ability, so they just like bold it to death, right? Just put it in bold. If I tried to do that on the board, I'd run out of these markers really fast, which aren't even mine. Okay? Every single time. So this is how we designate a vector. All right? So I always tell the story in class about the killing of Kennedy in Lee Harvey Oswald, which is not as good if we're not in class, but I'm going to try here. So the story is, and this is probably not real. I don't know, too. People think that Oswald shot a police officer on the way back, but I've also heard recently, I don't know if that's true or not. So let's say Oswald takes the shot, and no, I don't think there's any other shooters. I think it's just him, my opinion. So Oswald takes the shot. He leaves the, what's it called, Texas, whatever, book observatory or something like that, or conservatory or something like that. And he walks home. And I always say that his streets and his roads were like a grid, okay? So, like this, all right? And so let's say he starts here, and he walks home. Like that, all right? So you could say he walked 1, 2, 3, 4, 5, 6, 7, 8 blocks. I guess that would be true. 8 blocks he walked home, all right? And that would be a scalar, okay? Vectors, on the other hand, they take straight shots, okay? So the distance traveled by Oswald would have been 8 blocks home. But the displacement would be a straight line. Okay? The displacement would be a straight line. All right? So sometimes we could have words that we use very commonly like distance, but in physics we might mean displacement, so we need to be careful about that. All right? So Oswald walked a mile, 1 mile, okay, 1 mile northeast. So maybe that's how you could write it, okay, if you're trying to show a vector and give direction. All right. Another way is if we have a car. Oh, this is great. I'm an absolute. Well, here we go. It's not a spaceship. It's a car. Can't even tell if you're laughing or not. There's a car. I'll try to make them look even worse as the year goes on. That might be the better one. So, how about this? We could say, oh, the car's moving 5 miles per hour to the east. Okay? Something like that. I don't really necessarily like that, though. So when we're doing vectors on the board, we're going to basically most of the time call them plus and minus. So this would be plus 5 miles per hour. If it was going in the other direction, it would be negative 5 miles per hour. Okay, now why is that? Well, if we think about our setup here of x direction, y direction, this is positive x, this is negative x, positive y, and negative y. Negative y. Okay? Looks like a plus probably on the screen. So if I have a ball and I roll it across the table, oh, it's positive. If it goes backwards, oh, it's negative. If it goes up, it's positive. When it comes back down, it's negative. It's very simple, okay? Yeah. Now the best way to show a vector is like I did here with an arrow. Arrows are great because they give magnitude and direction. They're a certain length, they're a certain direction, and at this point we normally go into something called vector addition or subtraction, where we have multiple vectors and you have a vector here, and we kind of break them down and we show how they have a resultant vector and whatnot. But we're not going to do that this year. It's going to be a little hard if I'm not there. So I'll just put it this way about vector addition. I do not own a boat. I've heard the best days that people have with boats are the day they buy it and the day they sell it. I don't know if that's true or not, though. I've heard that from people, or at least somebody online. So let's say we have a river, and the river is moving this way with a certain speed. Well, I want my boat to go this way. What direction am I going to have to make the boat and paddle? Like this, to the side. So you could see that this vector plus this vector would equal that vector. Okay? And we could take any vector and break it down. So let's say, will this be seen well enough? I put markers in my pocket all the time. Are those different colors? Can you tell them there? Are they too close? Too close? How dare you? Okay. So, I probably should go on too much into this, but let's say we just call this vector A randomly. Okay? Well, vector A could have a, or an, whatever, an x direction and a y direction. Call that AX. We call that AY. And it has an angle here. And so any vector could be broken down into what we call vector components. Now, why bring that up? And why kind of bring up this vector addition thing? All right? Because in later chapters, we are going to have to do that when we have like projectile motion. So I'm going to launch a cannonball, and I'm going to hit a target. Projectile motion, two directions. We actually need this breakdown of vectors, which means, and a lot of us are going to be okay with this, some of us are going to hate this, trig functions. Okay? So that's the next thing we're going to go into is reviewing trig functions. There it is.